So in the first session of this week, we discussed about the basic set of features of object-oriented programming language. So we started with exploring what is an object. So object is a real-world entity which allows you to model it inside your programming perspective, and class which is a template which allows you to create similar kind of objects inside your application. And we discussed about encapsulation. So encapsulation allows the programmer to hide the complexity of the application. So whenever you decide the particular functionality should not be visible to the end customer, then you have to make it as private. So with the help of private modifier we can achieve encapsulation. And regarding abstraction, here we try to project the essential functionalities of the application. Whenever a developer decides a particular functionality should be visible to the end customer, then you have to make use of public modifier with that feature. So with the help of public modifier you can able to achieve abstraction inside your application. And we talked about inheritance. So inheritance allows you to reusable your existing code. So that is a major benefit of going towards inheritance. Apart from that, whenever you find that a particular class is insufficient to represent a logic, then what we do here is we will take the class as it is, we extend everything, and we will add some additional features into it and we will create it as a separate class. So that is also one of the benefit of going towards inheritance. And whenever we talk about inheritance, we come across two or multiple keywords like parent class can be referred it as superclass also. Likewise, child class can be referred it as subclass also. And whenever we say a particular class is a parent, it should be of more generalized. So it should consist of the common properties of all the child class. So likewise, we have to construct a class as a parent. Likewise, whenever we say a class as a child, it should be specific. It takes all the properties of the parent and it also have its own specific methods to represent the behavior of the child. So likewise, you have to define parent as well as child class. And we talked about two inheritance types: single inheritance and multi-level inheritance. With an example, clothing and shirt. And multi-level we discussed about you can have a parent can have one or more child, and the child will become another parent for its own child class. Then we talked about access control mechanism. So in Java there are 4 access controls. Modifiers are there. We have public, private, protected, and no modifier. And regarding public, whenever we declare the access modifier as public, so those members can be accessed from anywhere. Suppose if you declare some members as private, so private members are only accessible inside the class. Protected, you can able to access it inside the class and its subclasses. So subclasses may be in a same package or it may be in different package. So in case of no modifiers, members are accessible only by its class and it is of the same package. So you can access members outside of the class, but it should be in a same package. So it is a package level access modifier. And regarding super allows you to invoke the constructor, as well as if you want you can access the instance variable of the parent also. So we will see the simple demonstration of the usage of super keyword. So I'm going to create a class person. So I'm creating it as a person, and I'm going to have a child employee. So we have 2 classes, person so I have already defined employee, so I'm going to define it as customer. So I have a person class and I have a customer class. Now I want to make sure that person is a parent So I have to extend person. Now inside a person, so as I already told that it is a more generalized. So parents always is a more general form. And the child class are always specialized. So if you take person, so you can have common properties like name of the person, and person can have a particular age, then so can have some address. So likewise I have identified three properties or attributes for the person. Likewise if you take it as a customer, so customer is a specialized person. So here you can have something like customer ID. So every customer will have a customer ID, right? Then every customer may be of particular type, a regular customer or periodical customer. Likewise every customer has its own type. So likewise you can identify certain uh, generalized attributes as well as certain specialized attributes for the child. So now I'm going to have a method to display all the properties of person. So here we are going to display all the attributes of the person. So here I'm going to attach name, age and address. So I'm going to print name, then I'm going to attach age, then I'm going to attach address. So these are all certain generalized features of person class. And in case of a specialized version, you can print the details of the customers, customer ID and customer type. So here I'm going to print customer ID. So ID of the particular person. So I have attached customer ID here, and I'm going to print customer type. So we have added customer type over here. So this, for these properties I have given it as no modifier, but still it is preferable to go with encapsulation for the member variables. So you have to declare it as a private. So we'll come to that. So now we have two classes, person and its child is customer. Now I'm going to have a main method in a separate class. So I'm going to create a class test customer. So it is a separate class. Here I'm going to have a main method, and inside a main I'm going to create object for the customer class, and I'm going to invoke display customer, and I'm going to invoke display. So we haven't assigned any value, So we are simply trying to print everything. So everything with the default values is null for the string type, and for the age type it is 0. So we will see. Now we will see the usage of uh, super keyword, how super keyword can be used over here. So super keyword can be used in two different ways. You can invoke parent class constructor. It is one usage. Apart from that, you can invoke method of parent. You can invoke the method of a parent class. Then you can able to access instance variable of parent from child. So that is most important. You can able to access the parent properties from your child class. So these are all the three major usage of super keyword. So to start with, we'll see how to invoke methods with the help of a parent class method from the child class. For example, whenever we try to print the customer, we are only printing customer ID and customer type. So in addition to that, you need these information also, right? So now from this method, inside this method you can invoke display method, so which is of parent type. So if you want to invoke parent class method, you can use it like super dot method name. So suppose if you are invoking in that way, I don't need to invoke it from here. So now I'm going to rerun the code. So we are invoking only a display customer. Internally, display customer invokes display method of the person class. So likewise, with the help of super, you can invoke parent class method. Apart from that, still from the child, if you want to access the parent class instance variable, for example, we have instance variable like name, right? So customer name. So here I'm going to attach super dot name. So this is another way of accessing instance variable of the parent. So here what we have done here is we have used super keyword dot instance variable name. So likewise, you can able to access instance variable of the parent class also, super dot name. So now we'll look at the output. So name is printed once again. So the usage of super we discussed about. You can invoke method of the parent. Also, you can access the instance variable of the parent. Then one more usage is you can able to invoke parent class constructor, right? So I'm going to remove this. So I'm going to add a constructor. So because we haven't created any constructor, so constructor, it is a special type of method which does not have any return type. Simply I am adding a print statement, or typically we will initialize the value the start name, simply initializing it. The start age is equal to 18, something like that. Then the start address equal to, likewise you can initialize something inside your constructor. So I have a no argument constructor. You can put constructor anywhere inside your class. So I have a parameterized constructor inside my person class. Now inside my customer, I'm going to have a customer constructor. So customer, it is of class name. I'm using the same for the method name. Then here I'm going to assign customer ID. Customer ID equal to C123. I have taking it as an initial value. Then for the customer type, this dot type equal to is a regular customer. I can say something like make it as a regular. So these are for regular customer. So we have initialized some values, right? So now we'll see how to invoke a parent class constructor, right? Now I'll try to demonstrate the code. So here we have taken the values like name, age, address, then customer ID, then the regular customer. Everything comes with a predefined value, right? So what happens over here is, first of all, we are trying to invoke the customer's constructor. So the control will come back to customer constructor. So the customer's constructor, inside that we are simply assigning the values for customer ID and customer type, right? So regarding constructor, you have to remember the concept. So the first line of constructor, either this of or super of. So the first line of a constructor should be either this of statement should be there or super of statement should be there, right? Otherwise super of will be added by the compiler. Suppose if you fail to attach either super or this inside your constructor, then by default super of statements will be inserted inside your constructor. So this is about a constructor. Suppose if you want to invoke it manually, you can put it in that way. So here we are invoking parent class constructor, that is no argument constructor, from the child constructor. So the super of statement always be the first line of the child class constructor. Now we can also expect the same result, right? So everything comes with the initialized values of particular respective constructors. So now we had a discussion about the usage of super keyword with three varieties. So we discussed about how to invoke parent class constructor, how to invoke a particular method of the parent class. Then we discussed about how to access the instance variable of the parent class. So that's about super keyword. Now we'll come back. So we discussed about what is multi-level. What will happen in case of hierarchical inheritance? Suppose if we say hierarchical inheritance, so we show the class structure, parent 1. So I am creating a class parent 1, right? And I'm going to create another class child 1. So child 1 is going to be the child of parent 1. So in that case, this is single inheritance. So we have only one parent and we have only one child. So this is single inheritance. Suppose if you want to go for multi-level, so in case of multi-level, I'm going to create one more child. So I'm going to have a child 2 and extends child 1. So here the child 1 class will become a parent for the child 2. So this is multi-level. So in case of hierarchical, I can declare something like parent 1. So here what we have done, so for the parent 1 class we have a 2 child. So this kind of representation also possible in Java. So for the parent 1 class we have 2 child 1 and child 2, both the child of parent 1. So these kind of structures are known as hierarchical inheritance. But the important thing is, in Java you cannot extend more than one class. So, so that is that concept you should remember. So regarding inheritance, a class can have maximum one class as parent. So, so whenever we create a class, at the maximum you can have one parent. So it means that after extends keyword, you cannot attach more than one class. So cannot add something like comma. So that is not allowed it. So at the maximum, every child can have at most one parent in inheritance hierarchy. So that's about inheritance. Now we will come back to the usage of final keyword. So in Java we have three different usage of final keyword. You can create something like final with variable. You can use final keyword with variable, and you can use final with method, and you can go with final with class. So if you use final with variable, it will create constant in Java. So if you want to create constant in Java, you can go with final variable, and whenever you create a method as final, in that case the particular method cannot be overridden. So we'll discuss what is overridden. You cannot override it. Then if you declare a class with the final, in that case you cannot extend it further. So we'll see the usage of final keyword with a sample code. So I'm going to have a separate class as final demo, right? So final demo. So here I'm going to have a class student, or I can go with a product. So I'm going to go with the product as a class name. So inside my final demo, I'm going to have a main method. So inside this product class, I'm going to have something in final int discount. I'm going to fix some discount price equal to 10. Then string name. Here I'm going to attach a method to display everything. So here I'm going to print name, then I'm going to print the discount. So I have printed name as well as discount inside the display method. So here I'm going to create an object for the product class. Product equal to, so new product, then p dot display. Now we will see. So the default value of name is null and the discount is null. Suppose if you declare something as final, right? Suppose if you try to attach, so I'm going to change the value discount equal to 20, right? So we have declared it as 10 over here. If it is final, it will create a constant in Java, but here we are trying to change the value. Suppose if you do that, you will get a compile time error. The final field cannot be changed. So if you declare a variable as final, then you cannot change it. So this is a constant. So the value is same across or throughout the program. So this is for creating a final variable, or you can say constant. The next usage is you can go with the final class first. So for example, we have discussed this class, right? So we have a parent one. For the parent one, we have two classes. We have two child 1 and child 2, right? Suppose if I am creating here, I have declared my parent class as a final, right? I have declared this class as a final. So if it is final, then you cannot extend anything new, or you cannot create any child from the parent one. So here I have declared as a final. In that case, you will get a compile time error. You cannot create child from the final class, right? So this is the usage of final class. Suppose if you want to end the hierarchy of the inheritance, then you can go with the usage of final. Right? So that is the usage of final. So now we have discussed the two usage of final. Now we'll come back to final method. How we are going to define final method. So for example, so inside my parent one, I have a class. I have a method display. So display. So here I'm going to print it as. I'm going to print it as parent one. So we are inside parent one. And in Java, it is possible that you can have a same method inside your child. If you wish, you can have different implementation also. So here I have taken the same method name display, but I have written it inside my child class. So here I'm going to attach child one. Right. So I'm going to simply renaming it. Okay. So we have two classes, and I'm going to have a main class, public class test, public class test. So here I'm going to have a main. So inside this main, so I have to rename it. So I'm going to rename this file. So I'm going to rename the parent one into my main class name. So my main class name is test. So I have renamed it as test. So this is parent and this is parent, right? So now I'm going to create an object for the child. So child 1 c equal to new child 1, and I'm going to invoke c.display, right? So the problem over here is we are invoking display method with the help of child object reference. So inside a parent we have a display method and inside child we have a display method. So here whenever you apply inheritance, the parents method also inherited inside your class. So now if we try to invoke the display method, so we have two implementation for the display. In the first implementation we are printing parent one, in the second implementation we are printing child one, right? So now I'm going to run the code. So here the implementation from child one is being executed because of the object type is child, so you are getting the corresponding method implementation. Suppose if you decide that the child should not implement the same method of the parent, then you can declare it as final. Suppose if you are declaring a method as final in a parent class, then none of its child should implement the same method. So here I have declared display as final. Then if you declare the same method in a child, you will get the compile time error which says that you cannot override the method which is already defined in final. So with the help of final method, you can implement a function which is common for all the child classes, so that none of the child has its own definition for the final method. So this is another usage of final keyword. Whenever you declare a method as a final in parent class, then the child cannot has its own implementation. The child cannot override it. So that is a usage of uh, final keyword. So we have final keyword with variable, final with method name, then final with a class name.